Okay, we're recording, folks. We're recording right now. Thank you. So this will all be on the video. All right, here we go. Unlimited. Okay. Okay, so here we go. So I've got 4y squared. You're going to hear how many times on the video I have to shush you guys. We take 4y squared and multiply it into y squared plus 3 by doing the distributive property. That's really all we do to multiply things, right? When I multiply two polynomials together, it's just the distributive property. So what is it? What's 4y squared times y squared? 4y to the fourth. Now, what am I doing there? Am I adding or am I multiplying with those exponents? I'm adding, right? I am adding. Whenever we multiply things with like bases, we add the exponents together. Plus, and then I take 4 times 3 is 12, and then I drag along the y squared. Now, do I make that 16y to the 6th? Absolutely not. I wouldn't do that, right? Those are not like terms. One's a y to the 4th, one's a y squared. Pretty simple, right? Let's keep it moving. Even though it looks more complicated, it's really not as complicated. All I'm going to do is still just distribute in. Okay, that's all that's all I'm doing. 3 times 4 is 12. C times c squared is c to the third, because that's to the first power, right? 1 plus 2 is 3. I know it's the day after Christmas break, but 1 plus 2 is 3. No. D squared times d to the first is d to the third. And then I multiply in the second term. 3 times negative 6 is a negative 18. C to the first times c to the first is c squared. D squared times d is d to the third. And then I do the third distribution. 3 times 14, 42. 42 c squared d to the fourth. Is everybody following me there, how I get those terms? All I'm doing is multiplying common parts together. You know, the microphone is probably picking up you two, whatever comments you make over here.
You'll hear it all. Yeah.
Yeah, got it.
We'll all be there.
For anybody watching along at home, that is Lane and Ryan.
Last names?
None.
Okay.
We're still anonymous.
Keep it protected.
Yeah.
Of course.
Okay. All right, any questions about that? Okay. Don't touch my screen. All right. So now this is what's called, and you'll learn this a little bit more in section 6.1 video. This is a binomial, 2-term, times a trinomial, 2-term times a 3-term. All I'm going to do still is just do the distributive property, but I'm going to do it twice over. Here, 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 then here, here, here. Okay, that's all we're really doing. Just the distributive property twice. So let's multiply the a in. A times 2 is 2a. A times negative 5a is negative 5a squared. A times a squared is a to the third. And then I multiply in the negative 3. Negative 3 times 2 is negative 6. Negative 3 times negative 5a is a positive 15a. And then a negative 3 times a positive a squared is a negative 3a squared. Is everybody following me there? And now I just combine like terms. Make sure you put it into what's called standard form. Just making sure that it goes from greatest to least in the order of the powers. So a to the third comes first. And then I have my a squareds, negative 5 and negative 3 make negative 8. 2a and 15a makes 17a. Minus 6. Questions about that? Okay, so let's keep expanding it. Because no matter how many times, all I'm going to do is the distributive property. So if I have a trinomial times a trinomial, all I'm going to do is the distributive property. I had 2 terms to distribute in before. I now just have 3 terms. You see that? It's not difficult, it's just tedious. Okay? That's the difficult part about this, staying organized. Be very clear. Those of you who don't like to write a lot of work, good luck. Good luck on this one. X squared times x squared, x to the fourth. X squared times 5x, 5x to the third. X squared times -2, -2x squared. In the red, -4x times x squared is a -4x to the third. -4x times 5x is a -20x squared. -4x times -2 is a positive 8x. And then I do the green. Since it's just a 1, I can just copy everything down. X squared plus 5x minus 2. And now I just combine all those like terms. I've got an x to the fourth, goes away. I've got a 5x to the third and a -4x to the third. So just 1x to the third. I've got a -2, a -20, and a positive 1. X squared, so -21. X squareds, 8x, and a 5x makes 13x. And then I've got that -2 sitting up there on the end. Make sure you put it into standard form. Descending order in terms of the power. Questions? Does that make sense? That in and of itself, that's how you multiply. It's just basically the distributive property over and over again, as many times. Do you see how I could expand this to 4 terms times 4 terms, right? How many times would you be distributed? 4. Okay, that's really it. So let's talk about some powers. Please, people, please don't say this. This is not a to the third plus 2b to the third. Do not do that. You cannot just distribute that. Please don't do that. Please. You want to know what this really equates to? A plus 2b, a plus 2b, a plus 2b. Okay? So what does that imply? That implies that I need to FOIL this. I'm going to do the second 2 terms. You'll see why here in a second. I'm going to do the last 2 terms, last 2 products, last 2 factors. Now, when I say FOIL, remember that FOILing is really just the distributive property, right? Think about first outer. First outer, that's just the distributive property with my first term. Inner last is just the distributive property with my last 2 terms, or my 2b there. Right? So when I say FOIL, you just think distributive property. I'm going to carry this guy down, a plus 2b. Now, I'm going to FOIL that. First, a times a is a squared. Now, my inners and outers are going to be the same. They're both 2ab, right? My inners and outers are both 2ab. So together they make 4ab. My lasts, 2b times 2b, 4b squared. And then this turns into problem C on your guided notes, right? Okay. So we take a times a squared, a times 4ab, a times 4b squared. We take 2b times a squared. We take 2b times 4ab. We take 2b times 4b squared. Are any of those like terms? Yes. I have a to the third plus, here's an a squared b, here's an a squared b, 6 a squared b, ab squared, so plus 12 ab squared plus 8b to the third. You guys follow me there? Again, it's not difficult, it's just tedious. You just have to pay very close attention to detail in this. Be very clear about your work. Don't try to skip steps. I mean, I know I did from here to here, but don't. Do as I say, not as I do. All right, questions about that? Let's do the last one here on the front page, x plus 4 to the fourth. Ooh, something to the fourth power. This is fun. I've got this. Whoa. Okay, work smarter, not harder here. If I multiply these two together, isn't that the same thing as if I multiply these two together? Okay, so let's take a look here. X plus 4 times x plus 4. The first is x squared. The outer and the inner are both 4x to combine to make an 8x. My last 4 times 4 is 16. So that is really the same as this. Right? And now this becomes exactly like problem D. We all see that? All right. Let's take a look here. Multiply in with my trinomial times a trinomial. X squared times x squared, x to the fourth. X squared times 8x, 8x to the third. X squared times 16, 16x squared. 8x times x squared is an 8x to the third. 8x times 8x is 64x squared. 8x times 16 is, oh shoot, thank you, 128x. 16 times x squared, 16x squared. 16 times 8x, that's my 128x. 16 times 16 is 256. And then you just combine like terms. I got x to the fourth plus, looks like 8 and 8 makes 16. X to the third. I've got a 16, a 64, and a 16. So that makes 96 total x squareds. I've got a 128 and a 128x, so plus 256x, and then plus that 256 sitting out there on the end. Questions about that? Guys, pay very close attention to detail. Do not be messy about your work. Yeah? Try to be as clear as you can about your work. Okay, so that's really pretty much it in a nutshell. What I'm going to teach you on the backside of this is kind of a trick. A trick to expand binomials. Everybody turn your papers over. Now I can move this big blue box. I can let the cat out of the bag a little bit because you see it on your page there. But take a look here. On the left side of that table, I give you what a plus b is multiplied out to the fifth power. Okay? I give you a plus b raised to the fifth power. Because what's anything to the 0 power? 1. That's how I get my 1 on top. What's anything raised to the first power? Itself. So a plus b. 1a. So I get 1a plus 1b. If I square this, we're going to get 1a squared plus 2ab plus 1b squared. If I raise it to the third power, I get 1a to the third, 3a squared b plus 3ab squared plus 1b to the third. If I raise it to the fourth power, I'm going to get this. If I raise it to the fifth power, I'm going to get this. Now, we should notice something about those blue numbers in there. That is what's called Pascal's triangle. Have you guys ever heard of Pascal's triangle? It's pretty famous. It's one of the more famous things in math. It was really not really found by this guy named Pascal. It had been around for a long time. I think it's an ancient Chinese math that they found it back all the way back into there. But this guy, Blaise Pascal, yes, his name was Blaise. Cool name, Blaise. B-L-A, Blaise. Wow, Blaise Pascal. So if you're looking for, Chinese New Year, when is Chinese New Year?
Saturday, January 25th.
January 25th, we'll celebrate. So if you're looking for a good name, if you have a kid and you're thinking about what name, Blaise. Wow. But this guy Blaise Pascal really found a lot of the cool things that are in it and just wrote about it. Okay? It's not like he created it. This is not his, like he did not make this. This was there a long time before it. It just, he kind of saw a lot of patterns within it. So what are some patterns that we see? Do I have a big one here?
Yeah.
I don't. 1, 1, 1, 1, 2, 1, 1, 3. Actually, you know what? Shh, 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 shh. See, this is how many times I have to shush them. Everybody at home.
Hey, quiet, please.
Quiet please, thank you. So if you don't know how to make Pascal's triangle, everybody pay attention real quick. You start with a triangle of ones. Okay, start with a triangle of ones. Then every row must start and end with another 1. How do we get the next number? Well, we take the 2 numbers here and here and add them together. So this one is a 1. What's here? 3, 3, and then with a 1. This is a 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1. 1, 8, 28, 46, 70, 46, 28, 1. Okay, we'll stop there. Now, so there's some cool things that exist within Pascal's triangle. You kind of explore that a little bit when you do the task cards. Now, when I talk about the row number that you need, okay, the first row is considered what's called the 0 row. Okay, this is the 0 row. You could call this row 1, row 2, row 3, row 4, row 5. Basically, this is the row number. Okay, this is the row number. One cool thing that I always pick up on is that each row, if you take the sum of each row, it's 2 to the nth power, where n is the row number. Like if I add these two together, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and that pattern will continue throughout. There's other cool stuff. I think this is a pattern in here. I'll have to double check this one. I think if I take the third row, if I take this third row here, or this third diagonal, excuse me, all of those numbers are what's called triangular numbers. What does that mean? That means that if I could make a, like if I look at 3, I could make a triangle of dots with 3 dots. I could make a triangle of dots with 6 total dots. How many dots did I use? 6. That's called a triangular number. I could make it with 10. Right? 4, 7, 10. Yeah? And then 15, and then 21. I keep adding subsequent dots. Those are called triangular numbers. There's just really cool things that exist within Pascal's triangle. Now, what we are going to use it for is called binomial expansion. Binomial expansion. Here's what I mean by that. If I take a plus b and I raise it to the 8th power, if I take a plus b and I raise it to the 8th power, yes?
You get 46.
Oh, is that 56? Uh-oh.
You're very smart.
Uh-oh. That was Tyson Live. They corrected me right there. For everybody playing along at
I thought we
home.
weren't using last names.
Yeah, I thought that's the last name.
That was Ryan Moorhead and Lena Evans. All right. So if I take a plus b to the 8th power, see another shush. Everybody marking that down. If I take a plus b to the 8th power, everybody watch here. You're going to need to know how to do this. If I take a plus b to the 8th power. Now, can you understand how difficult this would be if I tried to actually write it out? Like we just did x plus 4 to the 4th. And that took us a while, right? Imagine doing something to the 8th. How long our expression is going to be at the end. Watch what I can do to simplify things. I know this 8th row are the coefficients on the binomial expansion, which means the final answer. Watch. I can say a 1 plus 8 plus 28 plus 56 plus 56. Oh, sorry, forgot my 70. Plus 56 plus 28 plus 8 plus 1. Those are all the numbers that are sitting out front. Now, I take my first term and I raise it to my highest power. My first term is A. I raise it to the 8. So this goes A to the 8. And then I decrease it as I go along. This one has A to the 7th, A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A squared, A, and then it should run out by the last term. Because the last term is going to have the second part of my product, part of my factor, raised to the highest power. So this is going to have b to the 8th all the way back here. And now I'm going to decrease it as I go to the left. So this is going to have b to the 7th, b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b squared, b, and then it's gone. And that's the final answer. No multiplying, no adding like terms. That's it. That's pretty cool, right? Now, could I have done this just expanding it out by hand? Of course. Right? So this is just kind of like a trick that you could do when it's a binomial raised to a certain power. So let's start here with x plus 2 to the 4th. X plus 2 to the 4th. We just did x plus 4 to the 4th, right? So we know how much time that's going to take. So what we need right now is the 4th row of Pascal's triangle. Right here. We need those numbers. That's the 4th, that's row 4 of Pascal's triangle. So here's what you do. You list out your coefficients. 1, 4, 6, 4, 1. I leave a lot of space. We can condense it in the end in a second. My first term is x, raise it to the highest power, then decrease. My second term is 2. It's not a letter this time, it's just a number. 2. Bring it to the highest power at the end, decrease going forward. And then it's not in the first term. And now we just evaluate that. So there's nothing left to do with x to the 4th, then just leave it x to the 4th. This second term, 4x to the 3rd times 2 to the 1st. Well, that's just 4 times 2, which is 8, x to the 3rd. The third term here, that's 6 times 2 squared, which is 4. 6 times 4 is 24, x squared. My fourth term, 4 times 2 to the 3rd. 2 to the 3rd is 8. 8 times 4, 32. And then it's an x term. And then we have 2 to the 4th, which is 16. In my mind, that's quicker than doing multiplying it out, in my mind. I think the breaking point is between x to the 3rd, or something to the 3rd power, a plus b to the 3rd, and a plus b to the 4th. When you raise it to a 4th power, it's quicker to do Pascal's triangle. If you're going to do to the 3rd power, it might just be easier to just write it out. But let's do a 3rd power using Pascal's triangle, especially when there's a negative involved. That can get a little tricky. So we got k minus 5 to the 3rd power. So I need the 3rd row. I need row 3. Row 0, 1, 2, 3. That's the row that I need. So we have 1, 3, 3, 1. My first term is k. So I take my highest power of k. K to the 3rd, k squared, k, and then it's gone. What's my second term here? Negative 5. Negative 5 over here, raised to the 3rd power. Negative 5 to the 2nd, negative 5 to the 1st, and then it's not in my first term. Okay, my first term is simplified as it is, k to the third. My second term, I've got 3, oops, I wrote a plus sign and it's not a plus sign. I have 3 times -5, negative 15k squared, so minus 15k squared. I have 3 times -5 squared. -5 squared is a positive 25. 3 times 25 is 75. Okay. And then we have, and I wrote a plus sign, and it's not a plus sign. 5 to the negative third power is negative 125. See, I think that takes just about as much time as if I were to try to write it out by hand. Right? FOIL it once. We did that on the front side in problem E. Right? Let's do one more of these. Somebody just knocking on the door. Is that somebody knocking on the table?
We should check the door.
All right. So let's try 6m minus 8 raised to the third power. What row of Pascal's triangle do we need? The row 3. That's the row that we need. Start out by writing out our coefficients. Taking our first term, raising it to the highest power, and decreasing each term. Take our second term, -8, put it at the end to the highest power, and decrease moving forward. Does everybody see what I'm doing there, how I create this? And now I just evaluate. 6 to the third power, I don't know that one up. And 216. M to the third, right? This one I do distribute the power to both terms because that's multiplication inside, not addition or subtraction. And then I have a 3 sitting on the outside, a 6 squared with the M, and then a -8. So a negative 864. So it's minus 864. Bless you, Lane. Just pointing it out who it was for those following along at home.
It wasn't Ryan.
It wasn't Ryan. Lane Evans. All right, and then we have 3 times 6 to the first times -8 squared, which would be just 64, right? 1152. M, and then minus whatever 8 to the third is. 512. Questions about that? Feel good about that? All right, I'm going to stop my recording.
Bye.
Everybody say bye.
Yes.